This is a GCSE Further Maths paper. It's a statistics unit, and this is from 2021. So this is just a wee walkthrough. Let's take a wee look at question 1. So 3 girls and 9 boys sat a physics examination. The 3 girls' marks were 92, 80 and 71. The mean of all 12 marks was 84. Calculate the mean of the boys' marks. So we got to work out the total for the boys' marks. So the total for all the marks is going to be 84 times 12. Obviously, to work out a mean, you add them all together and divide by how many there are. So this has just been divided by 12. So if we times it by 12 again, then it'll give us then kind of what we need. So 84 times 12, which I think then is 1008. And so then we need to take away the 3 girls' marks to work out the total of all the boys' marks. So it's 1008, take away 92 plus 80 plus 71, and if you do that sum in your calculator you get 765, and then the mean for the boys is going to be 765, and it says there are 9 boys, so we divide that by 5, and then the mean, sorry, by 9, and we end up then with 85%. So the mean for the boys is 85%. Part 2, the standard deviation of all the marks was 5%. Calculate the standard deviation of the boys' marks. So our standard deviation formula looks like this. And it's a sigma x squared bit is always a bit we need. We kind of get all those marks kind of squared. Take away 84 squared. So standard deviation of all 12 was 5%. So that's always in the amount that people there are, and this is the mean for them all. So if we square both sides, then we're going to get 5 squared equals sigma x squared over 12. Take away 84 squared. Hopefully you see what I've done. If you square this side, it just gets rid of the square root sign, and our standard deviation, it says then was 5, so my 5 squared, so it's going to be 25. So what am I going to do? I'm going to take the 84 squared over to this side and add it to the 5 squared, and then I'm going to times everything by 12. So the sum of all the x squareds is going to be 8, 4, 9, 7, 2. And again, check that in your calculator now and make sure that's the number that you get then as well. So we want then the sum of the x squareds for the boys, and that's going to be 8, 4, 9, 7, 2. Take away the other 3 marks squared. So the girls got 92, so we can square that, and 80 squared, and 71 squared. So if you take that away, you get 65,067. So that's my sigma x squared for the boys. So I'm just going to fill this back in again and find the new standard deviation then for the boys. So standard deviation for the boys is going to be the square root. So it's a sigma x squared, so it's 65067. We have 9 boys, and we've just worked out the mean, so this is always the mean squared here. On the previous page we worked it out, and it gives you 85 squared. You put that into your calculator and you get 2.16. So my answer then is 2.16%. Question 2 then looks like the binomial one. So complete Pascal's triangle in the grid below. So hopefully you realise it's always flanked by 1s going down here. So 1, 1, 1, 1, 1, 1. And then the way you work out Pascal's triangle is add the 2 above. So 1 plus 1 gives me 2. 1 plus 2 is 3. 2 and 1 is 3. And again, just always adding these. 4, 6, 4, 5, 10, 10. 4 plus 1 is 5, 6, 15, 20, 15, and 6. And then we have 7, 21, 35, 35, 21, and 7. Hence, write down the expansion of p plus q to the power of 7. So there's a wee bit of writing here. But we start with p to the power of 7. And then 7, p to the power of 6, Q, and there's quite a nice pattern here. Hopefully again you're well aware of it. So we take this number here, and as the powers of P drop, the powers of Q increase. So plus 21 P to the 5 Q squared plus 35 P to the 4 Q to the power 3 plus 35 P cubed Q to the power 4 plus 21 P squared Q to the power 5 plus 7 P Q to the power 6 plus Q to the power of 7. I assume that we're going to use this information then to answer the next question. A box contains a large number of green balls and white balls. 1/10 of the balls in the box are green. Joan picks 7 balls at random, chosen at random from the box. Find the probability exactly 2 of the balls are green. So because we're asked here for green, I'm going to let P be the probability, the green. 1/10 of the balls are green, so I'm going to go P, then it's going to be 0.1. Should have written it up as green, sorry. And then Q is the probability white, then it's going to be 0.9. And we need the probability of exactly 2. So exactly 2, so that's where P then is going to be 2, is going to be this one here, do you see it? So it's going to be 21 P squared Q to the power 5. And we put that information in, so my P is 0.1 squared. Sorry, it's not a plus at all, it's multiplied. 0.9 to the power of 5. That's a bit of a mess there, hopefully you get the idea. Stick it on your calculator, 21 times 0.1 squared times 0.9 to the power of 5, and you end up then with 0.12. Again, just check that on your calculator. At most, 2 of the balls are green. So that would be 0 green, 1 green, or 2 green. And so again, back to this. So it's going to be these 3 here. 21 P squared Q to the power of 5, 7 P Q to the 6 plus Q to the power of 7. Most 2 are green. As I said, then it's those last 3. So this one actually from above, 21 P squared Q to the power of 5 plus 7 P Q to the power of 6 plus Q to the power of 7. And we're just, anytime we see a P, we're exchanging it for a 0.1. Anytime we see a Q, we exchange it in for a 0.9 and fill in our blanks. So it's 21 0.1 squared 0.9 to the power of 5 plus 7 0.1 0.9 to the power of 6 plus 0.9 to the power of 7. We have this one already worked out, 0.12 above, so you can just add a 0.12 then to that and that, but if you fill all that in, you end up with 0.97. Now, okay, Alan recorded the ages of a group of boulders. The results were normally distributed with a mean of 65 and a standard deviation of 10. All the boulders aged 75 or over qualify for a free TV license. Find the probability the boulder chosen at random qualifies for a free TV license. My goodness. So my Z value, it's x minus mu all over sigma. So our x value here is 75. Take away 65 all over 10, and that comes out very straightforwardly. 75 take away 65 of course gives 10. 10 divided by 10 gives 1. And so in our probability of free TV license, we're looking for this bit here in the curve where it's 1, and we're looking for this wee area here. So remember that our graph doesn't give us that, so it's going to give us the white area whenever we kind of look up our table, and then we rearrange in from there. So let's write that down so we know what we're doing. So that's the probability that Z is greater than 1, because we're looking for this bit here. And that's equal to 1 minus the probability of z is less than 1. So the bit we're going to look at on our graph is actually this bit here, where that's 1. So 1 minus, and let's get our table, cosine graph. So it's 1.0, so because of 0, 0 there, 0.8413. So 1 minus 0.8413, and put that in your calculator, you end up with 0.16. Part 2, the bowlers aged 60 or over qualify for a free travel pass. Find the probability of bowler chosen at random does not qualify for a free travel pass. So 60 is our new x value here, so we're going to go z equals 60, take away 65 all over 10. And that obviously then gives us minus a half, or minus 0.5. So we're looking for the probability of not a free pass. That is the probability then that z is less than minus 0.5. So how does that look then on our wee diagram? We're going to have this. Obviously our mean is here, and we're minus 0.5, so we're down this side, and we want less than that, so the area we're looking for is that. Again, our table doesn't give us this, it only gives us from here up, so we need to do a bit of manipulation here. We're going to flip this over to the other side and do the sums, and then do 1 minus that. So the probability that we actually want then is 1 minus the probability of z less than 0.5. So how does that look in our little graph? Where that then is 0.5, I said we're minus 0.5 there, apologies. So we're going to kind of find that wee area there. So we're going to look up 0.5 and take it away from 1. That's what I've written here. So we can get our table, wherever it has managed to go. 0.6915. So 1 minus 0.6915, and my answer then we're just getting this one through 2 decimal places and less to ask for. Otherwise, sometimes you're asked for 4 decimal places here because they kind of give it to you in the table, but that's where our answer then is going to be 0.31. Okay, this is question 4. This looks like Spearman's rank and bivariate analysis. So let's take a wee look. Jane recorded her percentage marks in her winter and summer examinations. The results are shown in the table below. So we have these marks in for winter, all our subjects here, and these marks in for summer ranks. Right down in the table above the rank orders for winter and summer marks. So her best mark, of course it was maths. So for the winter we have 1 here. The next highest then I think is science. So we have 2, 77 is 3. Is that one there? 4 I think. And then the next one is 5, 6, 7, 8 and 9. The ranks in the summer, again maths was the highest. The next one, so that's 84. Where's the next one? With 2 and 82, so we need to be careful here. So this is ranks 2 and 3. So instead of writing the 2 and 3, we write 2.5 then for each of those. So that's 2 and 3 done. Some people now write 3, but you then go to 4. And so the next one's then below 82 are going to be 72. So that's messy as well. So that's 4 and 5 are both these ones. So they go in as 4 and 5. So remember we've gone through 5 here. 1, 2, 3, 4, 5. So we're now then on to number 6. So the next highest one then is here with a 68. And then 7. And then 8. And 9. Second part then, calculate Spearman's coefficient of rank correlation. So we're going to do our formula. I'll do the formula out first actually and see what we need. Alright, it goes 1 minus 6 sigma d squared all over n squared minus 1. So we need the sum of all the differences. So we need to kind of work that out there from there. So my differences, that's going to be a 0. That's going to be a 3.5 minus 2 minus 0.5 minus 3 minus 0.5, 0, 0.5, and then 2. And then we need to square each of those. So 0, 3.5, again checking our calculator, is 12.25. Minus 2 squared, remember, gives us a positive. That's 4. 0.25, 9, 0.25, 0, 0.25, and then 4. So the sum of all of these squares, again, you just need to put this into your calculator and find the sum. That's d squareds there. So the sum of all of these squareds, if you add all those up, I believe then it comes to 30. So let's fill in what we know. 1 minus 6 upon 30 all over n upon n squared minus 1. N in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9, and then 9 squared is 81, take away 1, then it's going to be 80. And R then is 0.75. So 0.75 gives you a result then for that. Interpret your answer to part 2. All I want to know is the fact that this is a positive number. It's quite a high. I'm tempted to say strong positive correlation, but I think I'll just come for strong positive correlation. That's all I want to know. So positive correlation. Calculate the mean winter mark and the mean summer mark. So mean winter mark. So what do we have to do here? We look at all the winter ones and we just add them all up again. I'm not going to do it now, but you add all those up on your calculator and it comes to 630. And of course there's 9 of them. So 630 divided by 9. You won't be able to do it in your head. That gives you then 70. So the mean winter mark is 70%. And the mean summer mark, you're going to add up all the summer ones. And again, take my word for it there, that's 648. Again, there's 9 of them, and that goes in then 72 times. So that then gives us 72. The data from the table are plotted on the graph below. Draw your line of best fit. So what we know about our line of best fit is that it needs to go through the mean of them both. So we're going to plot the point 70 and 72. So 70 across here, and up then to 72, so 71, 72. There's maybe look a bit different. And so we have that mark there. The next thing then we're going to do is try and draw on our line of best fit. So again, we want to kind of do it, I suppose, just sort of as best we can. So let me see if I kind of have it going through roughly here. Obviously, if you could do something like that, you're not going to get the marks, and everyone's will be slightly different, you see, so that kind of would make life a wee bit tougher. So I think something in and around here, perhaps. It's very, very hard to judge. But there's my line of best fit. There's no rule saying it needs to go through this point here, not that that is any point anyway, but that's kind of what we have. So that's my line of best fit then for the graph. I've kind of got roughly as many above as I have below, and it looks like it's vaguely kind of going through then the middle of the data. So that's where we are then from there. Determine the equation of the line of best fit which you have drawn. So we need to find the equation of that. So we need to find the gradient, and we need to find then the C part as well. So I'm going to look for a point. Now here's a point that's definitely on the graph. That's the point 70, 72. And another point that I've kind of spotted on the graph. Now, if you ever wits about you, realize I'm kind of cheating here slightly, but that's okay. I'm going to take that point there. So it's going to be the point 80, 81. So those are my kind of two coordinates, and I'm going to use them to work out the gradient. So my gradient is y2 minus y1 all over x2 minus x1. And so it was 81, take away 72, those are the two y coordinates, that's the mean obviously, that one. And my other point, so it was 80, 81. that gives you 9, and that gives you 10, and so we end up then with 0.9, which isn't awful. So that means my equation of a line looks like y equals mx plus c, y equals 0.9x plus c, and then to work out the c, I'm going to use again a point on the line. So I'm going to use this point here. So I'm going to change my y for a 72, 0.9 upon 70 plus c, and you take that, so that's going to be 0.9 times 70, you should know that as well. It's going to give you 63, subtracting that until you get c, then is 9. So that one's actually worked out quite nicely for us. So my equation of a line there is y equals 0.9x plus 9. Okay, question 5 then. County Cars offered automatic gearbox, parking sensors, metallic paint as optional extras with their new cars. Of the first 50 customers, 4 choose all 3. Choose all 3. So that's a nice way to start. We can have the 4 then in the middle. 6 gearbox and sensors. So there's gearbox and sensors. So because that's 6, obviously we need to have a 2 there. 5 is gearbox and metallic paint. So gearbox, metallic paint. So that's going to be a 1. 19 sensors and metallic paint, so 19 taken away from the 4 gives me 15. 10 chose gearbox, so we have 1, 4 and 2 here, so that has to be 3. 28 chose parking sensors, that takes us to 21, so that would be 7. And then 32 chose metallic paint, so that's 20 there, and so the 32 then would have to be 12. If you add all of these up, that's going to come to, I think it comes to 44, and that means there were 6 people then that chose nothing, so that's that bit filled in there. Part 2 then, calculate the probability that customer selected at random chose exactly 2 extras. So who do we have here that it's chosen 2? So this one here, and this one here, not this because that would be all 3, so it's 1 plus 2 plus 15, so it's going to be 18 out of the 50 people. So probability of 2 extras, I should probably have written 1 plus 2 plus 15, and that's all over 50. That gives me 18 over 50. Good to show you're working out here rather than throwing the 18 in case you make a wee mistake. At least you can get marks for your work in here, and then I think that cancels down hopefully to 9 over 25. Next part then, a customer selected at random did not choose metallic paint. What is the probability that this customer chose an automatic gearbox? Now there's a couple of different ways of doing this. This is a conditional probability one, but I just try and like to use my common sense for this and see if I can get the work out. A customer selected at random did not choose metallic paint. So we're forgetting about all the metallic paint people. What's the probability that this customer chose an automatic gearbox? So let's look back at this. We're not dealing with any of these people, so we're forgetting about them. They're not here. So out of all the rest, what's the probability they chose a metallic gearbox? So out of all the rest, we have 6 and 7, 13, 14, 15. We have 18 people we're dealing with here because we're not dealing with these anymore. Out of these 18 people, how many chose an automatic gearbox? The answer to that is 5. And that's all you need to do there. There will be a way of doing it with conditional probability, but I haven't chosen how to do that one. So in terms of the conditional probability, the probability that they choose auto gearbox, given they didn't choose metallic paint. I'll just show you that again so you can see where I'm getting it from. So we're forgetting about the people who choose metallic paint because we're given they're not choose. So out of these 18 people, we have 5. So it's 5 out of 18. Okay, final question then, the probability one. So a box contains 5 black bats and X red bats. Ben takes 2 bats without replacement from the box. The probability that both bats are chosen red is a 6. By forming the equation in X, find how many red bats are in the box. People find this confusing, so I'm going to do a wee cheat kind of over here, check and see. I'm going to make up some numbers. Let's say it was 5 black, and I'm checking this at random, 7 red. How would we work that out? Well, probably the first one they would take out would be 7 out of 12. And then probably the next one, there's now only 6 left. and it's 6 over 11. So instead of that, we have 5 black and we have x red. So we just do exactly the same thing, as complicated as it looks. So what did we do? We picked the 7 here, so I'm going to pick the x here. And then where did the 12 come from? It's that plus that. So that's going to be x plus 5. And we're timesing that by then. So there's now 1 fewer than x. So that's going to be x, take away 1. And there's 1 fewer here. So it's x plus 4. And we're told the answer to that then is a sixth. So I'm going to do top times top, bottom times bottom, I suppose. So it's going to be x minus 1 all over x plus 5, x plus 4. And tread carefully here, but I'm going to cross multiply. So I'm going to times the 6 here by this, so it's 6x upon this, and then this will go up here. So it's 6x upon x minus 1 equals x plus 5 upon x plus 4. And of course we're times that by 1, so I don't need to write that. This gives me 6x squared minus 6x. This gives me x squared plus 9x plus 20. And we're trying to solve this quadratic. Taking everything over to this side to keep it positive x squared. 5x squared minus 15x minus 20 equals 0. The way we'd solve that quadratic is divide everything by 5. X squared minus 3x minus 4 equals 0. Then I'm going to factorise that. Of course you can use a formula if you want, or whatever way you decide to factorise. So it's going to be x minus 4 and x plus 1. So the amount of bats is either 4 or minus 1. Obviously minus 1 can't happen, so the amount of bats we have then is going to be 4. I think that wee bit really helps me at the start. I just kind of make up numbers and then try and copy them from there. I hope that makes sense. That's us finished.